Okay, we're going to look at how to find limits algebraically. To do this, you're going to first apply substitution. This simply means you're going to take whatever x value of interest we have in the problem, and we're going to plug it into the function where we see an x. So for example, in this problem x is approaching 2. So what we're going to do is substitute in 2 where we see an x into this function. If we do that, we end up with 2 squared plus 1, which of course gives us 5. Now that is a defined value as opposed to undefined. It's a real number. We're done. So 5 would be our limit. And remember, that's the height that this function would be approaching if we were to approach 2 from each side. Now, unfortunately, it's not going to be that easy most of the time. Most of the time, after you perform your substitution, you're going to get 0 over 0. We have a special name for that. That is called indeterminate form. Indeterminate form means we can't determine what it is through direct substitution. So 0 over 0 means there's going to be an answer out there, but we have to do some work to find it. Direct substitution won't work. Now usually we're going to have a hole at the x value of interest if you see 0 over 0 after substitution. If this is the case, what we want to try to do is perform some sort of algebra. Now there's 3 different types that we're going to look at, 3 different techniques. The first one is to try to factor. Okay. Now you're not always going to have a simple factoring problem in front of you. Sometimes you're going to have to deal with a sum or a difference of 2 perfect cubes. So you're going to have to recall these formulas. If you have a sum of 2 cubes, then it's going to factor into x plus a times x squared minus ax plus a squared. And if you have a difference of 2 cubes, x minus a times x squared plus ax plus a squared. Notice the similarities and the differences between the two, so you have to commit those to memory. Now, if we can't factor a problem, what you want to look for is, well, can I multiply by a conjugate? This is our second technique. Multiply by a conjugate. You're going to use this technique when you see radicals in a problem. Okay? When you see radicals, or square roots, usually when you see a radical of some sort, you're multiplying by the conjugate. And we'll see an example in a little bit. And lastly, the third technique we're going to look at is to multiply by the least common multiple of the denominators. We're going to use this technique when you typically see fractions in a problem. Okay? And again, all of this deals with situations where you're going to get 0 over 0 in a problem. Once you have performed one of these algebraic techniques, always look to cancel like factors. Sometimes we say common factors. Okay, always look to cancel common factors and then resubstitute. Okay? So, let's look at an example here. Our first one, we have a function, and x is approaching 3. If we were to do our direct substitution right away, notice you're going to get 0 over 0. So, if we look at this numerator, x squared minus 9 can easily be factored into x plus 3 times x minus 3. Well, notice that we have common factors of x minus 3. They will cancel out. After they cancel, we're left with x plus 3. So we said that back up here, once we've canceled our like factors, you want to then resubstitute. So I'm going to substitute in 3 into this remaining x here and get my final limit, my final answer of 6. Okay? what we have here is another function, but this time x is approaching 9. And notice that if we were to plug 9 into this function, where we see an x, you would get 0 over 0. Right? So notice that there is a radical in this problem. Because there's a radical, that is your clue that you are going to multiply by what we call the conjugate. So the conjugate, we're going to multiply top and bottom by the conjugate. The conjugate is going to be the same binomial except opposite sign. So we're going to pick the part that has the radical in it. Okay? So we're looking to multiply top and bottom by the conjugate. So the reason we do this, if we were to do our FOIL, if we multiply radical x by radical x, you're going to have radical x quantity squared. Well, the square and the square root will cancel, leaving you with just x. So I'm going to carry over my limit notation. The limit as x approaches 9. So radical x times radical x is just x. Now the inner and the outer here, when we do our FOIL, they're going to cancel each other out. So all we really care about is the first and the last terms in each of these binomials. So when we multiply negative 3 times positive 3, we're left with negative 9. So we have x minus 9 up top. At the bottom, I'm going to keep this in factored form. I'm going to keep this as is. Remember, our goal is to look for a common factor that we could cancel out. Well, notice that we have x minus 9 and an x minus 9. Those will divide each other out, leaving us with 1 up top. So from there, we're going to resubstitute. I could put my 9 in where I see an x. So I end up with 1 over the square root of 9 plus 3, which will give us 1 over 3 plus 3, or 1 over 6 for our final answer. Lastly, let's look at an example where we see fractions. First of all, again, your first step is always direct substitution. If I plug 0 in for where I see an x, we're going to get 0 over 0. Because we see fractions, our clue here is we want to multiply by what we call the least common multiple. And what we want to do is we want to focus on our denominators. So if I focus on my denominators here, of all of these parts, I have a 2, I have an x minus 2, and I have a 1. Simply multiply those together, alright, keep it in factored form. That's our least common multiple. So what we're going to do now with that is we're going to multiply each of these terms by that LCM. So I'm multiplying each of these terms by that LCM. Now we'll notice that several things will divide each other out. So this 2 will cancel out with that 2. This x minus 2 here will cancel out with that x minus 2. Nothing will cancel on the bottom. So let's look at what we have remaining. We have the limit as x approaches 0. Our first term here, we have an x minus 2 left. I could take it out of the parentheses since there's nothing in front of it other than just 1, because those 2's canceled out. Plus, and then here I'm left with a 2. Okay, from that term. And then this is all over. I'm going to keep this in factored form, x times 2 times an x minus 2. Okay, I just put this 2 in parentheses here just to remind us that this is multiplication. Now up here in our numerator, that minus 2 and that plus 2, that just goes to 0. And then notice that we have an x up top and an x in the bottom, which will divide each other out. Again, it's in factored form, so we're allowed to cancel out those x's, leaving us with just 1. So if we look at what's remaining, we have the limit as x approaches 0 of 1 over, on the bottom I have 2 times, now I have an x there, so I'm going to put my 0 in there where I see an x. Okay. And when we clean this up, we're going to have 1 over, this would be 2 times -2, so that's a -4. So -1/4 would be our final answer. So again, we see fractions in this problem. That was our clue to use the least common multiple technique.